Welcome to Gruber Power Hour. I'm Janie.
I'm Pete Gruber.
And today we are going to touch on a topic that we're very familiar with, working in the critical power industry, how important it is that our customers proactively have themselves in a position to be successful if there was a power outage to occur. If there were power to go down and they were going to have a loss of load, what can they do strategically to make sure that they are planned for that event and what they can do proactively to get through it successfully with less amount of loss, you know, whether it be financial or with their equipment or any means like that.
Sure. You know, a critical step in maintaining critical power equipment, either on contract or on a time and materials basis, is you don't want to forego your preventive maintenance visits. And if we have a customer that's not on contract, we carefully track their preventive maintenance every 6 months. So when we go out and we actually look at the equipment to make sure that it's going to be able to weather a power outage.
The first approach is proactively doing that. Absolutely. And let's go through some of what we do with our preventive maintenance and our procedures there.
Sure. I did some research to collect the information, for what you need to look at, prepare for, how you need to analyze the equipment to make sure that it's properly functioning.
Right.
And I found really the best documentation was not on our website yet, and we are working on our website.
It's to come, yes.
Yeah. But we have a very thorough preventive maintenance list that I'm going to share that really that covers all of the things that need to be looked at to make sure that the equipment is up to par.
Okay, let's go through that.
First one, check and record the alarm logs. These the UPSs actually track events, and by going into the software, you can see things like brewing problems. Okay. Are there glitches in the system of some type? And that will prepare you. Are there low voltage conditions on the DC bus, for example? All of that is vital information during a preventive maintenance because it's a precursor to potential problems.
Now, do all units record a log?
Yes, the software is so inexpensive, and it runs on the systems anyway, and it's actually CAN signals, just like the cars use.
Right.
So just like the cars that we work on, like even the Tesla Roadster, which is 16 years old.
Right.
There is a, in the vehicle management system, there's a log file that is continually recording and always updating. And it's one of our main diagnostic tools because oftentimes you'll see problems beginning to brew before they even show up on what's called the vehicle display screen in the car.
Okay, which is fascinating. Yes.
So during a preventive maintenance visit, what we do are, and I'll give you hopefully a brief list here. We clean and replace all air filters. Now they have filters in them because they cool themselves using airflow or fans.
Right.
And you don't want dirty air blowing into your heat sinks, for example, because then you create a blanket of dust which actually holds heat.
And these are your typical like HEPA filters, things like that?
Yeah, these are very much the same as the filters you have in your home for your central AC systems or your thermal management in your home. Then we check all fans for slow start and free rotation. Slow start means if you have a bearing that's starting to go out, then it takes more energy for that fan to start spinning because it's gummy basically.
Okay.
And so by checking the fan for slow start, you'll be able to see whether there's a bearing starting to go out in a fan.
Now, would that be done as like a testing procedure as part of the testing through there, or do they just physically get in there and?
Well, they would, first they put you in a bypass so that your
Essential.
load and your equipment and your data center are running off another source.
Sure.
So that they can work totally on the UPS, on the critical power system, and do all of these checks, which is, powering it up and down.
Right.
It's during power up that you look for the fan rotation.
Okay, that makes sense.
And then check all of the AC and DC capacitors for swelling and for leakage. These capacitors act as filters, except for electronics, not air, not particulates.
Right.
But they filter the waveforms in the electronics. And then the other important part about capacitors is checking date codes. In a data center, you want 100% uptime. So people do proactive maintenance. Filter capacitors last 8 years.
Mm-hmm.
And if your date code says your cap is 10, 12 years old, yeah, it may still be working, but it's about to fail. And when it does, you're going to go down, you know?
Right.
So yeah, looking at the date codes on capacitors, and then in critical power, people do proactive maintenance. It's the same with the cars we work on, because a Tesla Roadster, the electronics aren't being made anymore. And you have 21 big electrolytic capacitors in the power electronics module or the inverter.
Right.
You don't want one of those to go resistive and fail, because when it does, it may take out electronics with it that are no longer in production.
Oh, wow. You know, I did notice that frequently and most often with our customers is they will come to us early on, the early stages of them being, 7, 8 years out, and have us proactively replace those things, whether it be the batteries within 3 to 5 years or the capacitors. Yeah, absolutely.
Yeah, there are other items, like you mentioned, the batteries. You don't want to wait until they reach end of life. You want to change them at the 3-year mark, so that when you really need those, when you've got a power outage, you have full ride-through time.
Absolutely. That makes sense.
Thermal scans on breakers, power connections, fuses, and controls. Thermal scans are very important in that when you have a breaker panel, for example, and it is during the first or the initial installation, all of the wires that are feeding the critical equipment out there, the breaker panel being fed by the UPS now,
Right.
Eventually the screw down portion of the output of the breaker into copper wire begins to loosen. And the reason it does is copper is soft, and you have compression that takes place, and eventually it begins to loosen up. The worst example was the old aluminum wire that they allowed during the 70s in this country, and began to realize not only is it failing, but it's also causing fires, because when you get resistance, it begins to arc and it creates heat. And in trailers, for example, where you had wooden paneling right by the outlet,
Wow. Yes.
it could create a fire. So because of the compression that takes place in the breaker panel over the years, what we end up doing is with an FLIR camera, thermal imaging, we can see the hot spots. We can see if there's any arcing.
Okay.
And that's another good preventive, measure.
Right.
The arcing not only causes potential fires, but it also causes intermittent operation, which is also a problem, of course.
Absolutely.
And then, of course, checking the DC capacitors, not just for date code, but they have vent caps. And if they've extruded more than 1/8 of an inch, then that's indicating that there's pressure building up inside the cap. Now, everything I'm describing to you here is what the field engineers do when they go out to do preventive maintenance. They've shut you down. I'm sorry, they've put you in bypass.
Wait a minute.
And everything they're doing is to prevent it from ever shutting down.
Now, just to, what we do when we go out there is we will do a bypass test on a yearly basis, and then we'll do our standard PMs on a semi-annual basis. Yeah.
Okay. And of course, it depends on the contract level too.
Sure.
We had some customers that needed quarterly PMs or even monthly PMs if it's NASA, for example.
Yeah, whatever they need, we'll take care of it. We'll be out there.
Zero margin for error.
Right.
Yeah. Visual checks. Now, this is all under visual checks still. Check subassemblies, wiring harnesses, cables for burns, broken wires. Here's an interesting one. Rodent damage.
Oh, yeah.
Some of these wires are made with soy insulation.
I just learned that recently as well.
Yeah. So those are things we look for. When I worked in I used to repair transmitters on like mountaintops for two-way radio.
Right.
And back east in the wintertime, the rodents would try to find a warmer place for their nests. They would go into these shacks, into these mountaintop transmitter buildings, looking for warmth. And of course, there was plenty back in the tube days.
Right.
So yeah, we were regularly clearing out nests. Sometimes you'd find a rodent strung across the cage inside a B plus where they had high voltage,
Oh, no.
and it was basically charred. Yeah.
Right. Great. Now, I'd be interested to learn more some other time about how they put soy into the wiring, how
Well,
that comes into play.
it's cheap, you know,
Okay.
and well, a wire has to have a form of insulation around it to, to prevent anyone from touching the conductor, which has voltage on it or signals.
Right.
So the insulation basically protects, against shock or against shorting because
Right.
it runs in conduit, which is grounded. And somewhere along the way, they found that soy was a
That material.
inexpensive material. Polyvinyl chloride is another method that they use.
Okay.
PVC.
Right.
But it's a big problem in the cars.
Right.
Yeah, for
That's
us.
what I've experienced over in GMC. Yeah.
And once you get a rodent in a Tesla Roadster or any sort of an EV or a car,
Right.
the type of damage they do is very expensive to repair because oftentimes it's in channels where wiring harnesses run.
Mhm.
You can't quite even see it or reach into it. So you have to replace the whole thing in order to fix something like that.
Wow. Okay.
All right.
That would be pretty.
So that was under visual inspection. Then we have the operational inspections, and here's where they check the bypass voltage and frequency for proper available power. These are all done with sophisticated meters and the type of equipment that can check the electronics.
Okay.
Then we also check power quality and harmonic distortion levels based on special request. Harmonics are definitely something that you don't want in your electrical circuits. Then they check the input voltage, of course, the amperage available, frequency for proper levels and balance. In the United States, everything is 60 hertz, but the question is it really? Well, there's some times where the utility has begun to deviate from what is expected, and it can affect the equipment.
And we have all the testing equipment that runs all this that we go through.
Mm-hmm.
All the different meters and things like that we've got.
Exactly. Yeah. Both the battery type meters, we use sophisticated Midtronics equipment to do all the DC tests, the battery tests. And then Fluke is another popular brand. We have oscilloscopes and frequency meters. All of that gets tested. And we're attempting to establish that the incoming power is correct and that the output power from the UPS is the correct frequency, voltage, and has the capacity necessary for the load.
Okay.
All right.
What else do we have?
And
here?
then pending approval, perform operational system tests, including unit transfer and battery discharge. This is where we actually simulate a power outage. We then take readings and recordings. How is the DC plant or the batteries or battery cabinets supplying the inverter? What kind of amperage is there? And what is the ride through time?
Okay.
So all of that is carefully monitored, and we're simulating basically a power outage. And then internal component inspections. We check the static switch voltages and inspect for any leakage. The inverter voltages and balances for proper operation. The inverter is the part that converts the DC to AC. And then the rectifier voltages and the current balance for proper operation. What the rectifier does in a UPS is its function in life is to take AC and convert it to DC to charge your batteries.
Right.
And then we also take care of any engineering change orders, field changes. The equipment may have been deemed as needing a particular change in a component, a resistor that was improperly sized, whatever it is.
Okay.
We then take care of the engineering change orders that need to be made to update that equipment to current rev levels. And then finally, external environmental checks. We check the ambient temperature of the UPS room. Electronic equipment likes to operate within a certain temperature and humidity range, very much like humans, oddly enough.
They react to it.
Except in the old mainframe computer rooms, it was actually cold in there. They tried to keep it in the low 70s, 70 to 72. And So yeah, we check the environmental conditions. If you have an uninterruptible power system in a hostile environment, and by hostile, let me give you a classic example.
Hmm.
They put UPSs in traffic lights.
Okay, outside in the elements.
Exactly. Then you'll
Right,
see a big steel box off the pole right there,
right.
which has the timing functions for the red and the yellow lights and green lights. There's oftentimes a UPS in there. Well,
Wow,
picture this. This thing is usually in direct sunlight and
absolutely.
painted green, dark green, which of course begins to hold heat.
Drawing all that.
So you've got something baking inside there. That's probably the worst hostile environment for an uninterruptible power system. Now, thankfully, they're usually small UPSs, 1 kVA, 500 VA, that type of thing, half a
Okay.
kVA. You would not want to do anything like that with a large UPS, 500 kVA, 300, 250, because
Oh,
it's not going
absolutely.
to survive well.
Absolutely not. So they must change those out frequently then.
Oh, very much so, yes. Yeah, the batteries, they don't even last a year oftentimes.
Wow. Okay.
And then, of course, the downside is if somebody hits a telephone pole somewhere and it drops power to the traffic light, you don't have any lights.
Right, which we've seen happen.
Right. We check the location for cleanliness, accessibility. If it has access floor, for example, which is quite common in computer rooms, we check to see if there's any kind of water underneath the floor. It's
Okay.
not uncommon for a couple of reasons. One is if you have a chilled water system, which instead of HVAC,
Well, that's exactly where
Freon.
my mind went, is that you're
Mhm.
going to have that having water coming out of it at the same time.
And if you have a leak, then you're going to have a tub basically that could fill up with water.
It's a dangerous situation.
It is. Most data centers have water intrusion or water detection sensors under the access floor.
Okay.
The other reason for that is plumbing problems, in the building that could migrate in underneath your access floor. And the reason it's oftentimes undetected is if it's in a room, an office room, you see a wet carpet, you see water on the tile floor, you
Right.
immediately recognize you've got a leak. Under an access floor, everything is hidden.
You don't see it. You don't know.
Right.
Right. Or even where these units are operating, it's not in a place where you're walking into the room daily,
Mm-hmm.
you
Right.
know, so it's off somewhere in another room.
Right.
Yeah.
Then we check for service clearances, service access, service clearances.
Mhm.
According to code, you've got to have at least 30 inches behind the equipment so that you can open a door, walk behind it,
Right.
And it may have been moved since we were last there. So we advise the customers, I see you've moved it. However, you're no longer in code compliance. And if there's any kind of code inspection that's done, fire
Right.
inspection, for example, anything like that, they're going to cite you and fine you for that.
Well, all of these items that we've read through absolutely lead to why it's important to have a trained field engineer go out and do these services rather than somebody trying to do them themselves, that hasn't done it before or isn't familiar with the equipment.
Right. And self-maintenance, although, doable on smaller equipment,
Right.
yeah, like you say, there are a broad range of skills involved here, from electrical to, code compliance type issues to electronics, reading the logs, going
Right.
into the actual,
To know what to look for in there.
right. And then, of course, having the equipment necessary to do that.
Right. Of
The
course.
average owner doesn't have any of that. Or if they have a maintenance department, they may have some skills.
Sure. That makes sense.
And then the final portion that we spend a lot of time during a preventive maintenance, and by the way, all of this is going to be on our website. We're rebuilding our websites right
Yes.
now. And I'm sometimes amazed when I go to our website and I say, why isn't this out there? How did we miss that? It is, this list that I'm giving you, though, is available during when we do the paperwork for a service agreement. We give you a complete list
Indeed.
of options and what we do, and all of that is, that's
Part
provided
of
to
the
our
service
customers.
plan. Absolutely.
So getting into the battery system now, what we call the DC plant. And again, the reason we use DC batteries is because you can't store AC.
Mhm.
If you could, then you wouldn't need batteries. It's a redundant or a inefficient way to store, but because you have to convert the DC back to AC. So for the battery system, we inspect the batteries for any swelling. Swelling, typically with a battery, indicates that there is some heat buildup taking place within the battery, which is indicative of either arcing or the electrolyte beginning to dry up. It's becoming resistive.
Right.
So that's one of the first indication that your battery is starting to go bad. Then we retorque any connection points as necessary. We spoke about that earlier with copper wires being inserted into a circuit breaker, and then you've got a screw that's clamping down on it. Well, the same is true with your battery system. You've got a bunch of high amperage connections, and part of our PM procedure is to take every single one of those 10 millimeter connections or whatever they are,
Right.
and then torquing them to specification, which now eliminates any looseness.
That makes sense at every connection point that we go back and check.
Mm-hmm.
Absolutely.
Inspect for any corrosion at the connecting points. Well, in the wet cell batteries, just like the batteries that you have in your car, for example, those are called wet cells. You have caps that you can remove, and what's sloshing around in there, sulfuric acid.
Okay.
Well, as you're charging those batteries, there's some venting taking place, and the fumes are corrosive, and they will eventually settle on your connecting points. That's why when you open your trunk, especially on the older cars, you'll see sometimes copper oxide or green residue on your connecting points.
Oh, yeah.
So what we end up doing is we inspect for any type of corrosion, especially with wet cells. And some, computer rooms and still use wet cells because they have a longer lifespan.
Oh, yeah. I've known many of our customers that do.
Mm-hmm.
Yep.
Then we record battery date codes and the number of cells and strings. The reason for that is proactively replacing your batteries is very important, because the worst time to find out that your battery system has problems is during a power outage. And that's
Indeed.
typically when it occurs.
Absolutely.
If you have an automatic transfer switch that switches you to a generator, that usually gives you 5 to 7 minutes. Well, if you don't have 5 to 7 minutes of runtime on your battery system, it's never going to hit the transfer switch, and you're going to go down.
And you'll lose that.
Yeah, you'll never get the generator to fire up through the automatic transfer switch system. We record battery date codes. That's another good indicator of how old your batteries are and whether they need to be replaced. We recommend 3 years for batteries. Now, they may go 4 years, they may go 5 years, but are you willing to gamble?
Yeah.
Especially for a critical load. We just had a power outage here actually last week. Let's talk about that.
All right. Well, we can go there.
We were in a podcast just like this, and suddenly everything went dark, pitch dark, and silent in this room.
Wow.
So we found our way out of the room. We got to get some emergency lights in this studio.
Some walking lights to get through here.
We're still building out the studio, so that hadn't been done yet. But it turns out that our utility, because of some construction in the neighborhood, killed power in about a 5 square mile area here. A number of businesses were down.
Right.
Well, the problem is when you go down abruptly like that, and it's not a clean, scheduled power outage, where you're shutting things off methodically, you can hurt hardware. It damages hardware. We lost 2 switches in that hardware. Now, picture this. There were over 100 people that were on computers in 3 different call centers. Nobody could work during that power outage. We had UPS in 2 of the buildings, and they were able to continue to work for about 5 to 10 minutes, but it was an extended power outage, and we didn't have an engine generator, so we eventually had to shut down those UPSs as well. So now people are literally sitting there twiddling their thumbs. Look at the amount of productivity loss.
A loss is enormous when you have so many people
associated with that. Yeah,
absolutely.
So, spending a bit extra on your critical power infrastructure makes sense when you consider when these disasters happen, what kind of losses you could incur. Well, it took us, 2 days, 3 days before we actually came back up completely.
Fully functional again, indeed. It's not only the loss of the employees not being able to work at their desk because their computers are down, but it also affected our phone lines.
Yes.
And then we have customers
Incoming business stopped, basically.
Right, right. Well, thank goodness that we have our emergency phone number for our customers that have an agreement with us. So they always have a means of getting a hold of us, no matter what. But as far as being able to make any calls outbound or inbound, it affected us completely.
So that's the reason for a bulletproof backup system, uninterruptible power
Well, that's
system.
part of what made me think of this podcast is thinking of, what can companies do strategically to plan ahead of time and be sure to have a plan in place? What do you do when something does happen? How are you going to respond to it to get you going again as quick as possible in those critical moments?
So then we do individual battery load testing as well. String voltage, meaning that we do the entire string, all 40 cells connected in series, or we do individual testing as well, especially if we're finding that the date codes are reaching end of life. Because now you need to go to that next level to find out if there are any that are, beyond being able to be used during a power outage. If your batteries are rack mounted, and we're on the VRLA or the battery system at this point, we inspect the rack system for structural integrity. These batteries weigh an enormous amount. Some are 100 pounds apiece times 40. Now you've got 4,000 pounds.
Oh, absolutely. And you've got them stacked up and down. Yeah, absolutely.
Did I do that math right?
What did you say? I didn't calculate.
100 pounds 40.
Yeah, you're good.
Okay. I was with my granddaughter, and
did she correct you?
Well, no, it was. I don't think they're teaching the same level of math in schools these days.
Oh no.
Making change type things. She's a straight A student now, mind you. So I was impressed.
Right.
Until we tried to make change.
Well, I noticed that with percentages and division.
Yeah.
There seems to be, with, I hate to say this, but with younger generations, when I go to them about calculating different percentages and dividing it to come up with your percentage, there seems to be this lack of knowledge of how to do that. I guess they've gotten used to calculators and things to do there.
We used to extract square roots longhand as well.
Okay.
Yeah, and I think these days only a calculator can do that anymore. Anyway, I don't know how I got sidetracked.
I know, that's okay. We both did.
So, yeah, we inspect the racks. Sometimes in wet cells, for example, you have sulfuric acid, and it can compromise the mounting structures. The bolts, for example, get corroded and, lose some of their strengths.
Right.
So we tighten bolts as necessary, and we replace any if needed. We check the system float voltage. Now, this is a term that is related to wet cells. And inside wet cells, they're actually clear, and you can see the fluid, which is sulfuric acid. And we check the pH, the amount of acid, and then add, as needed. So that's what float, and then the float voltage is the voltage on the actual cell itself. And then adjust if necessary. We clean and retighten all terminals and connections, and then we put no oxide grease on them to make sure that corrosion is inhibited. And then finally, we measure individual battery temperatures and check for any hot spots or readings which are out of the manufacturer's recommended specs.
Okay. But these are definitely good points for highlighting what you can do to proactively prevent as much loss as possible when there is a power outage.
And that's
plan ahead of time. Get your PMs done.
That's why it's called
have a maintenance agreement so you don't have to worry about scheduling those PMs to be done. Having the proper plan. If it does, you do have that loss of load and the UPS is up and running. Does that transfer switch work effectively, to ensure to switch over to your generator power? Making sure that you are prepared in those events to have the proper backup and coverage when needed.
So one of the final things that we do is we now have the main load or the data center, or whatever it's powering, on a bypass system, so we can go through the entire functionality. the final thing that we end up doing is testing it all the way through, from simulating a power outage
Right.
to allowing the automatic transfer switch to start its timing function, and then turning on the generator at some point in time, which has to start up and warm up and all that,
Right.
and then continue to supply power, so that we've actually simulated a real live power outage.
So that way we know they're going to be effective when they need it. You know, some of our customers even have a redundancy plan where they have additional equipment set up. So in case there was something to happen, they have another unit listed there as backup. They have backup to their backup,
Sure.
you know.
You know, that was a popular concept in the 70s and 80s, especially in the banking industry.
Oh, yeah.
And there was a computer mainframe company that started. They call themselves Tandem computers.
Okay.
And the reason was exactly that. You would have two. I'm sorry, two computers. We're talking about computers now. I keep going back to UPSs.
Yeah.
So you would have two computers running simultaneously, running the same software, and if one quit or had a problem, the other one continued to run. Yeah.
Oh, yeah. I could see that in their math, the kind of, you know, calculations that they're doing.
Oh, in the banking industry, you know, they lose enormous amounts every second when they're, you know, moving funds around and collecting interest payments and all that.
Absolutely.
So one of the things, too, that we offer is a program called Auto Notify, which is a method whereby we email our customers periodically what is due, what needs to be done on their UPS
coming up,
system.
alerting them to which units they have. Will specifically identify which equipment is needing that service and when it's needing it.
One of the most popular ones is the battery notification. You know, your battery is going on 3 years now, 3 years plus, and it's time to consider replacement of battery because this is the window where they begin to fail. Then we have the contract renewal. You know, worst case scenarios are the contract expires, accounting wasn't doing their function properly, and suddenly there's a problem in the UPS and the contract has expired. So we're very good about notifying customers, letting them know ahead of time when their contract is about to expire so they can proactively sign up again.
We don't want to have any lapses in there.
Totally, yes.
Absolutely.
Yeah. So the Auto Notify program, and it is free, completely free, even if you're not on contract with us and you want us to notify you when your preventive maintenance is due because you're self-maintaining, let's say.
Right.
We'll put you in the system and we'll send an email every 6 months if that's your PM cycle, or every year.
That it's time. Absolutely. It's very useful for those customers because you have somebody, you know, you have your IT manager, your facilities manager, and there's so much they're responsible for to keep track of on their day-to-day ins and outs. And they've got this unit running in the background, you know, that they're responsible for. So absolutely.
Sure. So I think we've covered all of the items that we do during preventive maintenance.
Indeed. And it's just one of the things to ensure that you're keeping your units in the best shape possible in case of an outage or a loss of load. And we will continue these variable or different topics coming up over the next few weeks about what we can do for the equipment.
And, you know, I began thinking, I think we're the only ones in the critical power industry that are doing these kinds of podcasts that are actually allowing people to chime in or view them later on. And
to reach out to our customers.
Yes, and our goal is to provide relevant, informative content, including the videos that we have out on our YouTube channel, which help keep your equipment running and keep you apprised of things that will help your uptime.
Absolutely. Very good. Well, thank you so much. And everybody have a wonderful weekend now.
Yeah. Thank you for joining us.
Take care.